MS Ramaiah University of Applied Sciences.
Hello students, in this video we will be discussing the milling machine and its attachments, cutting tools and subsequently dealing with different types of operations performed on milling machine. The learning objective of milling machine and its operations are to provide hands-on experience on milling machine, to identify the various parts of milling machines and its attachments, to select the various types of cutting tools based on the applications, demonstrate the different types of operations. Introduction to milling machine. Milling is the machining operation that removes metal by feeding the work against a rotating cutter having multiple cutting edges. Flat or curved surfaces of many shapes can be machined by milling with good finish and accuracy. A milling machine may also be used for pockets, slotting, making a circular profile and gear cutting by having suitable attachments. Applications of milling machine. The various types of milling operations performed by milling machine include end milling, groove or slot milling, keyway cutting, profile milling, face milling. Principle of milling. The workpiece is mounted on the table, can be fed either in the direction opposite to that of rotating cutter or in the same direction of the cutter. Generally, there are two types of milling processes, namely up milling, that is conventional milling, down milling, that is climb milling. Up milling process, that is conventional milling. The major disadvantages of up milling process are the tendency of cutting force to lift the work from the fixtures and poor surface finish obtained. But being a safer process, it is commonly used method of milling. Down milling process, that is climb milling. In this method, there is less friction involved and consequently less heat is generated on the contact surface of the cutter and workpiece. Removes more material for passage of each tooth compared with conventional milling, that is up milling. Another advantage is that it consumes slightly lower power since there is no need to drive the table against the cutter. Types of milling machines. According to general design, the distinctive types of milling machines are column and knee type milling machines such as head milling machine, plane milling machine, universal milling machine, turret type milling machine, vertical milling machine, fixed bed type milling machine like simplex milling and duplex milling, special type milling machine like rotary table milling, drum milling, planetary milling and tracer controlled milling. Horizontal milling machine. Horizontal milling machine is one of the most popular type of milling machines and is so named because the spindle is horizontal. Horizontal mills are optimal for machining heavier workpieces because the cutters have support from the arbor as well as a bigger cross-sectional area than a vertical mill. Vertical milling machine. The vertical milling is similar to the horizontal milling machine except that the spindle is held in a vertical position. The workpiece is mounted on the table with the help of suitable fixtures. A suitable milling cutter for the specified job is chosen and mounted on the spindle. Milling operations that can be performed on vertical mill includes face milling, end milling, pocket milling and contour profile milling, etc. Universal and planar milling machine. Universal milling machine. This machine is used for making of helical grooves, helical gears and helical flutes of twisted drills. Planar milling machine. It is used to milling the strong straight surfaces on large and heavy machine parts. Fixed bed type milling machine. These machines are having one horizontal spindle on one side or two spindles over each side are called simplex or duplex machines. These machines are larger, heavier, and greater rigidity than the column type of machine. Work holding devices. The accessories are employed for handling and supporting the workpiece on milling. The following work holding devices are commonly used in milling machine, namely angle plate, V-block, plane vise, universal vise, and swivel vise. In addition, some of the work holding devices used to clamp directly on the bed of the machine like step block with strap clamp and strap clamp with V-block. Milling machine attachments. The following attachments are commonly used for additional operation can be performed on milling machine like vertical milling head, rotary table, rack milling attachment, and rotary indexing table. In addition, we can use rotary tables with additional 4th and 5th axis for 3D profile machining. Types of milling cutters. The milling cutters are classified into various types based on a variety of methods. Based on the construction, solid and inserted types. Based on mounting, arbor mounted, shank mounted, and nose mounted. Based on rotation, clockwise and counterclockwise. Tools and tool holding devices. The figure shows the end mills and inserted types of cutters along with adapters for holding the tools. Arbor milling cutters. Slot milling cutters are generally mounted in arbor of the horizontal milling machine, and these tools are generally used for machining of gears and slots. Slab mills are used either by themselves or in a gang of milling operations to machine large, broad surfaces quickly. T-slot and dovetail milling cutters. These cutters are used for machining of slots and dovetail shapes on the machine bed. Types of milling operations. The various types of milling operations performed by milling machine include plane or slab or peripheral milling, end milling, slot and saw milling, angular milling and straddle milling, helical milling and gear cutting. Types of milling operations. The basic cutting operation can be performed by peripheral and end milling method. Peripheral milling. In peripheral milling, the tool axis is parallel to the machine's surface. The operation is performed by cutting edges on the outside periphery of the cutter. End milling. During end milling process, the tool axis is perpendicular to the machined surface. The operation is performed by cutting edges on both the end and outside periphery of the cutter. Peripheral milling operations. Plane or slab or peripheral milling. It is a method of producing a plane, flat horizontal surface parallel to the axis of rotation of the cutter. The cutter width extends beyond the workpiece on both sides. Side milling. It is the operation of production of a flat vertical surface on the side of a workpiece by using a side milling cutter. Face milling operations. Conventional face milling. It is a method of producing a flat surface at right angles to the axis of the cutter. Partial face milling. The cutter overhangs only on one side of the workpiece during machining. Special milling operations. Straddle milling. Similar to side milling, but cutting takes on both sides of the workpiece simultaneously. Slot milling or slotting. In this operation, the end mill cut the slot on the workpieces by side and face milling cutter. Saw milling. If the cutter is very thin, it can be used to cut a workpiece into two pieces. Angular milling. It is a method of producing a flat surface making an angle to the axis of the cutter. Gang milling. Two or more cutters having same or different diameters mounted on the arbor of the milling machine. T-slot milling. In this type of operation, T-slot cutter is used to make the T-slots on the workpiece. Additional operations done on milling are keyway milling, gear cutting, helical milling, that is square threads, helical grooves. End milling operations. Pocket milling. End mill is used to mill shallow pockets into flat parts. Profile milling. End milling is used to cut the outside periphery of a flat part. Milling machine. Now we will discuss the vertical milling machine and its parts. Vertical machine is very similar to a horizontal milling machine. Workpiece is mounted on the table and cutter is mounted on vertical spindle. Feed is given by movement of saddle and table and also vertical movement of tool. The spindle head may be swiveled at an angle, permitting the milling cutter to work on angular surfaces. This machine works using end milling and face milling cutters. This machine is adapted for machining grooves, slots, and flat surfaces. Parts of vertical milling machine. The major parts of milling machine are namely base. It gives support and rigidity to the machine and also acts as a reservoir for the cutting fluids. Column. The column is the main supporting frame mounted vertically on the base. The column is box-shaped, heavily ribbed inside, and houses all the driving mechanisms for the spindle and table feed. Knee. The knee is a rigid casting mounted on the front face of the column. The knee moves vertically along the guideways, and this movement enables to adjust the distance between the cutter and the job. Saddle. The saddle rests on the knee and constitutes the intermediate part between the knee and the table. Table. The table rests on guideways in the saddle and provides support to the work. Vertical, that is up and down movement provided by raising or lowering the knee. Cross, that is in or out, or transverse motion provided by moving the saddle in relation to the knee. Longitudinal, that is back and forth motion provided by hand wheel fitted on the side of feed screw. Spindle. It gets the power from gears, belt drives to drive the motor. In vertical milling machine, spindle may have fixed head, swiveling, or slidable swiveling head spindle. Knee elevating screw. The upward and downward movement to the knee and the table is given by the elevating screw that is operated by hand or an automatic feed. Hello students, now we will learn the milling operations on milling machine. This is the milling machine we are going to use for milling the work surface. Initially, we measure the original length, width, and thickness of the workpiece using vernier caliper. Mount the workpiece rigidly in the machine vise. Switch on the milling machine using the green button for clockwise rotation of spindle and height adjustment by upward movement of the table using hand or an automatic feed method. For the motion of the table from left to right by rotate the auto feed lever. Stop the spindle using red button and check the dimension using vernier caliper. Repeat the steps for further process.
At MSR UAS, we spark your imagination unlike any other.